All right, so when we're talking about graphing data, there's a bunch of different graphs we can use. We can use bar graphs, pie charts, or line graphs. Those are the three most common. There's several others we can utilize as well, but we're going to stick with these three. So there's different times that it's better to use different graphs. So the graph that helps us show the relative sizes of quantities under different conditions would be a bar graph. This is where we're showing like how many people were wearing different colored t-shirts. That would be a good example to use for a bar graph. So this says this graph shows how one quantity changes as conditions change. It makes it easier to see general patterns in the data. That would be a line graph. So a line graph is going to look like this, where we can see if things are increasing or decreasing, whereas a bar graph is going to be separate, so it's showing that these things aren't necessarily connected, like there's no correlation from one to the other. Like if going back to that t-shirt example, that the number of people wearing blue t-shirts didn't affect the number of people wearing black t-shirts. So, and then the last one, this graph helps to show the relative sizes of parts of a larger whole. Anytime it's talking about parts of a whole or percents, you're always going to want to use a pie chart. So it's asking here to list two examples where it would be more useful to use a pie chart than either a bar graph or a line graph. And it's always a hint as to where percentages are usually used. So an example, if you wanted to show the percent of students in each grade level, that would be a great pie chart. Or if you wanted to show the percent of money spent in different areas, that would be another example of a great use for a pie chart. So if you were spending money in 4 different areas and you wanted to show how much you spent in each one, that would be an example. So it says to use this graph for the next couple questions. So we have the coyote population starting from 1990 to 96. It says rangers at Boxer National Park keep count of the coyotes and become concerned if the number of coyotes is below 300. In which years do the rangers need to be concerned about the coyote population? Well, they said they were concerned when it was below 300. So here's the 300 line, and we're going to list out all the years it was below 300, which would be 92, 94, 95, and 96. Those would be the 4 years they would need to be concerned. Other than that, it was above 300. So from what you can tell by the graph, during which 2 years were the coyote populations increasing? So if you look back at your graph, when you're looking for where it increases, you're looking for where one bar is here and the next bar beside it is a higher bar when it's going up. And it was increasing in 1993 and 1996. Both of those show the population being higher than it was the year before. So which year had the largest change in population from the previous years? Well, in order to figure that out, I need to figure out how much each population changed. So I'm going to list out all of our populations. So we had our years of 90. So I've listed them all out here. You can flip back to your graph and look at this, and it wants to know which year had the largest change in population. Well, from 90 to 91, it went down 50, and from 91 to 92, it went down 70. Then it went up by 30. Then it went down by 30. Then it went down by 40, and then it went up by 40. So the biggest change happened in 1992 because it went down 70. That was the largest change. So then it says the coyote population depends on the year. So estimate the coyotes population in years, or C of Y for 93, 95, and 92. When you see this notation, all it's saying is to look at your table, because I've already done my table. So it says to look at the table and look at 93. Well, at 93, there was 310, so that would be my answer. At 95, there was about 240. And at 92, we said there was about 280. So those would be my answers. So we're supposed to use this pie chart here to represent the next few questions. So this pie chart represents how many birds that we're seeing. So it said 17% of the birds were others, 34% were finches, 24% were robins, and 25% were jays. So the question says, which type of bird would you most likely see at the feeder in August? Well, we're going to most likely see finches because that's the one with the biggest percentage. So in August, the jays and the robins make up more than half of the birds at the bird feeder. So wants to know, is this true or false? Well, there was 25% of them were jays and 24% were robins. If I add those together, I get 49%. So the question is that more than half? And the answer to that is no, it is false. Because that is not more than half, that's less than half. It says if there were 68 finches at the feeder in August, how many birds came to the feeder in all? Anytime you're talking about percents and you're solving percents, you always want to use a proportion. So when we set up our proportions, it's always our percent over 100 equals our part over our whole. That's the way it will always look every single time. And you just have to figure out what information are you given and what numbers go where. So we know we're going to have something over 100. And so on top of 100 should be our percent. Well, it wants to know about finches, and finches was 34%. So 34 over 100 equals, and remember on top it's going to be our part, and on bottom it's going to be our whole. So it said that there were 68 finches. Well, it wants to know the total bird feeder, so that means I don't know my whole. I know my part was 68. And so then to solve this, I'm going to cross multiply and divide. So when I cross multiply, 100 times 68 is 6,800. And that equals 34x. And then I'm going to divide both sides by 34. And I end up with x equals 200. So there was a total of 200 birds in the month of August. And lastly, if 340 birds came to the feeder in August, how many of them would not be blue jays? So again, I'm going to have to use a proportion. I know it's going to be a percent over 100. So we're talking about what's not blue jays. Well, looking back, we know that the blue jays, or the jays, was 25%. So that means the rest of it that was not a blue jay would be 75%. And on the other side, that's going to be my part over my whole. Well, it says there was 340 birds. That's a total, so that's going to go on bottom. And my part that I don't know is my x. So again, I'm going to cross multiply and divide. So 100 times x is 100x. 75 times 34 is 25,500. And then I'm going to divide both sides by 100. So x is going to equal 255. So there would have been 255 birds that were not blue jays that month. So we're going to read this bar graph here. So this park rangers have watched a black bear named Samson grow up. The line graph shows the measurement they have made of Samson's height. So it wants to know what was the bear's height when he was 3 years old. So at 3 years old, if I go up, there's my point, his height was 2. Okay, well, it asks us for the next question, what is h of 3 minus h of 2? Or in other words, thankfully it's really nice and it tells us what is the difference in his height from ages 2 to 3. So that means that we need to subtract those. Well, we know at 3, h of 3, his height was 2 meters. So at 2 years old, his height, we'll say, is about 1.4. So h of 2 would be 1.4, and we need to subtract those. So we're going to do 2 minus 1.4, which is going to give us 0.6 meters. So that was the difference in his height. So judging by the graph above, at what age did Samson reach his full height? Well, he'll reach his full height when his height starts to level off, when it doesn't change from year to year. And it's increasing from 1 to 2, it's increasing from 2 to 3, it's increasing from 3 to 4, but from 4 to 5, it's staying the same. So that means at 4, he reached his full height. Starting at age 1, about how long did it take for Samson to roughly double in height to 2 meters? So it's asking how many years it took from year 1 to get to 2 meters. Well, year 3 was when he was at 2 meters, so it took him 2 years. All right, we're going to answer the odd problems as usual. So in months, how many months were the high temperatures over 60 degrees Fahrenheit? So this chart shows the high temperatures every month for an entire year. So it wants to know how many months were they over 60. Clearly these people didn't live in Texas. So we're looking at 60 is here. And all of those months that have points above that are months that are in over 60. So that would be 1, 2, 3, 4, 5, 6, 7, 8. There was 8 months that it was over 60. And number 3 says, in how many months was the high temperature below 70? So this time we're looking at when the high was underneath 70. So we're going to draw a line at 70. And we're looking for all the months underneath that. Well, that would be January, February, March, and April. And then October, November, and December. So there was 7 months that it was below 70. Number 5, which language? We have this pie chart we're supposed to read about the foreign language class enrollment. So which language has the fewest students enrolled? Well, that's going to be one with the smallest percentage, which is Latin. Question 7 says more students take Spanish than take Latin and French combined. That's what should be there. You can see that on the next page. So we need to figure out how many take Latin and French combined. So Latin is 15%. French is 18%. 15 plus 18 is 33. So 40% take Spanish. 33% take Latin and French combined. So is it true that more students take Spanish than Latin and French together? That is true because 40 is bigger than 33. And number 9, we have this bar graph. It says summer jobs of high school juniors. So and the options are whether they worked in restaurants, farming, retail, or office work. So number 9 says more students worked in a restaurant, so this bar graph, than they did farm work. So this would be this bar graph. So the question is there more in the restaurant than the farming? And that would be a true statement.